If you've ever automated a compliance scan, you've probably met this. Thousands of lines of XML. This is SCAP, 2 decades of automated compliance checking, in a format you cannot read, you cannot easily change, you cannot separate from the tool that runs it. So question, what if a compliance check were something you could simply open and read? Let's start with the real problem. In the old model, the check is code. Whether you pass or fail is decided by logic buried inside a scanner, written for that scanner, tangled together with how it runs. To read the check, you read a program. To trust the check, you trust the vendor who wrote it. ESP takes that apart. ESP is a policy language built on one idea. A policy describes what should be true, not how to check it. The intent becomes data. The execution stays separate, and the author states the security requirement. The scanner decides how to collect it. The one split is what makes a check something a human can actually inspect. So let's open one. This is a real ESP policy. One file. It checks a single control on a Kubernetes cluster. It opens with meta, the metadata block, where the policy declares its intent. A unique identifier, the platform it targets, how critical the control is. Then the line an assessor looks for first, the control mapping. This check states inside the file itself exactly which control it satisfies. This is STIG hardening requirement, the NIST 853 control behind it, CM5 sub 6, and it carries its own implementation narrative, how the control is met in plain language. So the test and documentation cannot drift apart over time. They are the same file. Below meta is def, the definition. This is the check itself, built from 2 simple parts. First, the object, the thing being inspected. Here, one file on the host, the kubelet configuration file. The object only names what to look at. It holds no logic. Second, you have the state, the condition the thing must be in. 2 requirements. The file must exist, and its permissions must be 0644, writable by the owner, readable by everyone else, nothing more. You see, you read those 2 blocks out loud, and they're almost English. This file should be in this state. That is the entire check. An assessor does not read code to understand the policy. They just read the policy. So 2 parts remain, and they're what make ESP safe to run. The CRI block, the criteria, ties everything together. The object, the state, joined by a simple logic, and inside it sits the CTN, the criterion type node, the actual unit of checking. This has a type, file metadata. See, this type is a key, and the CTN type is bound to a contract, a fixed, predefined, whitelisted way of collecting that one kind of data. The policy itself contains no command. It cannot run an arbitrary script. It can only call a contract that already exists. No improvised code ever reaches the endpoint. Before any of this runs, the policy goes through the ESP compiler. See, the file is untrusted input, and the compiler treats it that way. 7 passes, every reference resolved, every type checked, against limits compiled into the binary. You see, it's a fail fast. So if anything goes wrong, the policy is rejected right here before a single endpoint is touched. What comes out on the other side is a validated structure the engine can trust. Same policy, same system state, same result, every run. No inference, no heuristics, no AI. So talk about why it matters. Just step back and look at what that buys you. See, the methodology is open. ESP is open source. Apache 2.0, the compiler, the engine, the rules. Anyone can read exactly how a result is produced. To audit the method once, do not re-audit it on every scan. And it is one language. See, the ESP structure expresses a variety of frameworks. This is STIG, CIS benchmarks, 853, across every platform. So you learn to read one policy and you can read them all. That's a check anyone can read, a method anyone can audit, and the result is same every time. That is what policy as data delivers. So one last connection. In the replay hash video, the replay hash is signed by three things: intent, contract, and outcome. Now you have seen where the first two come from. The intent is a validated policy. The contract is a CTN binding that runs it. It's what makes the proof possible. It's a check precise enough to hash and open enough to trust. See, the engine is open source. Go read it. github.com/Scanset/Endpoint State Policy. See, ESP is a compliance check you can actually read.